Alright, so let's start talking about the inverse of cosine. So the first thing I'm going to do is same thing I did before. I'm going to draw out the cosine curve for you really quick, and then we're going to see what the inverse cosine curve looks like. Okay, so this is what the cosine curve looks like. Starts at its max, ends at its max, hits its minimum in the middle. There we go. And then if I extend it in this direction, looks like the same thing. Alright, this is cosine of x. Okay, so obviously the same thing occurs. If I am looking to figure out what the inverse cosine of x looks like, first thing that I need to do for any inverse function is to figure out if it passes the horizontal line test. And this clearly fails the horizontal line test many, many times. But that does not need to be the end of our discussion. Instead of looking at the entire cosine curve, what if I just look at a tiny little piece of it? Last time we looked from here over to here. If we did that same thing this time, it would fail because it crosses here and it crosses here. So this time we're going to look between 0 and pi. We're only going to look at that tiny little section. So between 0 and pi. So I'm going to restrict my domain. You're going to hear me say that a lot. I'm going to change my domain or restrict it. And instead of looking at every single value of x on my domain, I'm only going to look at the values between 0 and pi. And you can see how I highlighted that part of the graph in blue right here. So we're only going to look at that tiny little piece. And I could go ahead and erase all the rest of this, but it just kind of makes it more messy. So my domain is between 0 and pi, and my range is still between -1 and +1. Now because I restricted my domain, it passes the horizontal line test. Therefore, when I flip it over the line y is equal to x, my inverse is going to be a function. So let's come over here and graph what that would look like. Instead of doing the inverse of sine, I'm going to type in second cosine of x and graph that. And I need to actually change my window because this is between 0 and pi this time. So window between 0 and pi. And graph. Oh, okay. I know what is going on. It actually, it's weird. It shifts it and it makes it taller up here. I need to change my window just a little bit bigger between -1 and let's go all the way up to 5, just so that we make sure that we see that graph. Okay. Actually, I still can't see it. I need to see some on the left-hand side. I'm really sorry, John. I'm going to go between -pi and +pi. Enter, graph. There we go. Okay. Cosine. The inverse of cosine curve looks like this. And it kind of sits up here on top of the x-axis. So that's clearly different than what we saw over here for the inverse of sine. This one, I know that my diagram isn't necessarily the best thing in the world, but this one, just like the sine curve, inverse of sine actually goes right through the origin as well. Inverse of cosine clearly does not. So that's another way that you could remember it if you had to pick out one of these on the test. Inverse of sine goes through the origin. Inverse of cosine does not. So that's the domain and the range for cosine of x, because I had to restrict my domain right here. So if I want to know what the domain and the range of the inverse of cosine are, my new domain is -1 to +1 because I'm flipping these two values now, and my new range is between 0 and pi. Alrighty. Okay, last one. Nope. We are going to talk about inverse of tangent. Okay. Last one, and then we're done with all of the new material for this section, which is awesome. So, this is what the graph of tangent looks like. And I can do it in this direction as well. Theoretically, you should have arrows on the top and the bottom of all of these, but I am using a computer, and that is slightly difficult. So this is what tangent of x looks like. And clearly, hopefully you can see that that obviously fails the horizontal line test as well. So does that mean that there's no inverse of tangent? No, that just means that we have to be slightly more creative. So clearly it fails the horizontal line test. So what we're going to do is restrict the domain yet again, and instead of looking at every single one of these curves, I'm only going to look at one of them. I'm only going to look at this one. And my new domain is going to be, again, between negative pi over 2 and positive pi over 2, which is the same thing that it was for the sine function. Okay, so my new domain, my restricted domain, is between negative pi over 2 and positive pi over 2. And my range, in this case, because tangent extends on forever in positive and negative direction on the y-axis, it's actually all real numbers. Okay? So if I'm only taking that section, then that clearly passes the horizontal line test. Now I can flip it over the line y is equal to x, and we're going to see what that looks like. I'm going to type in second tangent of x, and I'm going to change my window yet again. I'm going to go between negative pi and positive pi. You can make these whatever you want, John, as long as you can see the picture. Whoops. Oh my goodness, why is this not working? Because I can't push the right buttons. That's why it's not working. Graph. Okay. This is what the inverse tangent function looks like. It actually has asymptotes, the same thing as tangent does, so it actually goes along this line, crosses through the origin, and then goes along that line. So the new domain, or the new x values, as you can see, is going to be all real numbers, and you can see that by looking and seeing how it extends in the negative direction and the positive direction as well. And then the new range is between negative pi over 2 and positive pi over 2. Okay? So, I mean, that's something that you really do need to remember, so I would make sure that you have that written down. Okay? Let's see what notes Ms. Tompkins says. To form the graph of the inverse of sine, or arc sine, this is just another way that we use to say inverse. Arc just means inverse. Okay? You're going to reflect the graph of sine of x over a line y is equal to x. Okay, so I'm going to skip through this stuff because we already did this. That's what inverse sine looks like, inverse cosine, and inverse tangent. The graphing calculator is programmed to graph arc sine, arc cosine, and arc tangent, or, you know, inverse sine, inverse cosine, and inverse tangent as functions. Therefore, the domains are already restricted. So pretty much when we graph those things, you don't see the whole function because, or you don't see like all of the curves that you would have seen on tangent because we already, the calculator already restricted the domain for us. See how it did the work for us that I showed you. And that is about it. Okay, so I haven't heard from you in a couple days, so I need to know if you have the practice test for this chapter, which is chapter 11. If you do, hopefully I will see you tomorrow and we can go over that together. If I don't see you, then I'm going to just keep on moving right on to chapter 12 information, and you can ask me any questions that you need to. So you need to have all of the homework assignments done for chapter 11 material, and once you have all that stuff done, you can hand it in to Abby, and Abby will get it to me. You can take that chapter 11 test as long as you feel comfortable, but I'm telling you that you will be asked to graph sine, cosine, sine and cosine functions. and the rest of it is kind of like matching, okay? It's completely up to you whether you want to take it now or if you want to ask me questions. So I'm going to move on to more material. So I will hopefully talk to you later. Okay.